Hi everyone, this is Sunita, Assistant Professor in ECE Department, Siddhartha Academy of Higher Education, deemed to be University. In this class, we will see the forward biased PN junction diode, reverse biased PN junction diode. In previous class, we have seen up to just the formation of the PN junction. That means open circuited. We are not applying any external force to that junction. That means just PN junction is formed, open circuited PN junction. In this class, we will see the forward bias and reverse bias PN junction diode and characteristics, VI characteristics, voltage and the current characteristics of the PN junction diode, and the breakdown mechanism in reverse bias, diode equation, diode resistance, DC and AC diode resistance and diode capacitance, transition capacitance and diffusion capacitance. In the final, we will see the current components in the diode. Biasing. Unbiased means no applied external force. The forward bias means the P terminal of the diode connected to the positive terminal of the battery and N terminal of the diode is connected to the negative terminal of the battery. Reverse bias means the positive terminal of the P terminal of the diode connected to the negative terminal of the battery and negative terminal of the diode is connected to the positive terminal of the battery. This is P type and N type. So when the PN junction is just formed unbiased, already we have know that there is a formation of the depletion region which opposes the flow of the charge carriers. So this is the in forward bias connection. The battery positive is connected to the P type material and battery negative is connected to the N type material. See here, what will happen when uh, applied force is increases. Suppose applied force is 0, no force is applied. There is no flow of charge carriers because there is a barrier which suppress the flow of charge carriers. That is called a depletion measure. What happens when you increase the applied voltage? Suppose the barrier potential voltage is 0.3. we are going to increase the applied voltage by 0.1. Is there any current? No, because the potential which is opposes the flow of the current, further diffusion of charge carriers from B2 and N2 is 0.3. The applied voltage is 0.1 volts. There is no flow of the charge carriers. Then 0.2, no. Then 0.3, yes. Beyond the 0.3. So when the applied voltage is greater than the depletion layer voltage, the potential which opposes the flow of the charge carriers, then there is a start of the movement of the charge carriers. So in the forward bias condition, we know that the holes are majority charge carriers in P type, electrons are majority charge carriers in the N type. So the battery positive is connected to the P type. Both has the positive charge and the same charges get repelled. Repulsion occurs. In N type, electrons has negative charge and battery terminal negative. So both repel. So these electrons move towards the junction. Here these holes moves towards the junction. So that means the depleted area width decreases. That means the lack of charge carriers here, the depletion is filled by the holes. Here the filled by the electrons. So whenever the applied voltage is increases, the width of the depletion layer decreases. At the certain point, the width of the depletion layer makes 0. Then there is a flow of the charge carriers from P to N and N to P. So in the forward bias condition, the applied voltage is greater than the depletion layer potential. There is a flow of the charge carriers. In the forward bias condition, the width of the depletion layer decreases. There is a flow of the charge carriers from P to N and N to P. Finally, in the forward bias, there is a flow of the current. The same thing is applied here. Forward bias depletion layer with decreases. So under the reverse bias, once imagine that diagram in the back side. In the reverse bias applied, that means the P terminal of the battery is connected to the N terminal of the diode, and the negative terminal of the battery is connected to the positive terminal P of the diode. That means opposite charges. The holes, for the holes P type, we connected to the battery negative charge. So opposite charges are get attracted. That means the charge carriers holes move away from the junction, at the same time electrons move away from the junction. That means the junction, there are no charge carriers, because the depletion layer width, that means the depletion layer width increases. In the reverse bias, the depletion layer width increases. There is no flow of the majority charge carriers. But in the p type, there are minority charge carriers electrons. In n type, there are minority charge carriers holes. So in reverse bias condition, there is no majority charge carriers current. Okay, but due to the movement of the diffusion of the minority charge carriers, there is a diffusion, electrons in p side to n side, holes in p side to n side. So due to the movement of the minority charge carriers, there is a small amount of the current. That current is called the saturation current. Nearly that current in terms of the microamperes. The forward bias current in terms of the milliamperes, reverse bias current in terms of the microamperes. So this is the VI characteristics of the silicon diode. The depletion layer width is uh, different for the different materials. For the silicon, zero point 0.3, for the silicon 0.7, for germanium 0.3, like that. So here the silicon material is taken. That means the PN diode, the base semiconductor is silicon, and that silicon, the impurities added, intrinsic, extrinsic impurities pentavalent, trivalent. So from that PN junction diode is formed, like that. Silicon PN junction diode is to, that cut-in voltage is 0.7. That means the barrier potential depletion layer offers the potential up to the 0.7 volts. That means the applied voltage up to the 0.7 only. There is no current. After that only there is a increase of the current. So see here up to 0.5, here approximately 0.5 to 0.7. The current rapidly increases at the 0.7. So say up to the 0.5 there is no current. From 0.5 to 0.7 there is a small amount of current. After that there is a increase in the large, exponentially increases. In reverse bias, see in reverse bias, this curve is due to the reverse saturation current due to the movement of the minority charge carriers. Here after that certain applied voltage, this x-axis voltage in volts, applied voltage in forward applied voltage, y-axis in positive current through the diode. In forward bias it is in the milliamperes. In reverse bias the applied voltage in the negatives, that means reverse bias. So after certain point, after applying the certain point, the junction break down. Here in reverse bias a breakdown occurs. There are two types of the breakdowns: avalanche breakdown and the Zener breakdown. Next slide I will explain what is avalanche breakdown and what is the Zener breakdown. Remember that point. In the reverse bias, the current due to only minority charge carriers, then the current in terms of the microamperes are always negligible. Microamperes current. This is the diode equation. So the current through the diode ID is equal to IS. IS means saturation current, reverse saturation current. The current through the diode when it is in the reverse bias, e power Vd by eta Vita, where Vd is the applied voltage. Applied voltage. In characteristics we have seen the x-axis applied voltage and y-axis current through the diode. So here ID is the current through the diode, Vd is the applied voltage, eta is the intrinsic constant, Vt is the volt equivalent temperature. Here the volt equivalent temperature Vt is equal to K capital T by Q. Q is the charge of electron, K is the Boltzmann constant, and T is the temperature in Kelvin. So is -1. This is the ideal diode equation. We can calculate in some problems they will give the temperature and saturation current and applied voltage and the type of the material. The eta depends upon the type of the material, that means silicon or germanium, which type of diode, like that. They'll ask what is the current through the diode. So we can calculate ID is equal to IS, saturation current, e power of applied voltage by intrinsic constant into volt equivalent temperature minus 1. This is the ideal diode equation, the equation for the current through the diode. It shows the relation between the applied voltage and the current through the diode. This is a symbol for the schematic symbol for the PN junction diode, anode and cathode, P-type material here, N-type material here. P-type material, N-type material, structural representation. This is a symbolic representation. So now we can define diode. So diode, this is a two-terminal device which allows the current in one direction and opposes the current in the other direction, which flow of current to flow in one direction while blocking the current flow in the opposite direction. So we know that this is the block diagram representation. Circuit, in circuit we will represent PN junction diode like this: P-type terminal and N-type terminal, anode and cathode. So this is the real PN junction diode diagram. This is a anode and the cathode, P-type and N-type. The forward bias, how we can represent diode in the forward bias means the positive terminal to the p type, negative terminal to the n type. In reverse bias, negative terminal to the p type and positive terminal to the n type. So what are the applications of the diode? So diode has vast applications, and on that some of the applications are acts as a switch. So we already discussed about the importance of the semiconductors in first lecture. The semiconductors, the main aim to control the flow of the charge carriers. There is no controlling of the flow of the charge carriers in conductors. That's why we came to semiconductors. There is a controlling charge of the control over the flow of the charge carriers. So it acts as a switch. When diode is in the I'm talking about the ideal diode is in the forward bias condition. It acts as the on switch, short circuit. So this suppose this is the forward bias condition. This one is the forward bias condition. Forward bias condition means the depletion layer with 0, and there is a flow of the charge carriers from p-type to n-type and n-type to p-type. That means this short circuit. In reverse bias, the diode acts as an open circuit. So open circuit means open block. This block. So there are no further movement of the charge carriers from p-type to n and n-type to p. So as a switch, it acts as in forward bias, it acts as an on switch. In reverse bias, it acts as an off switch. It acts as a rectifier, and the special purpose diodes like light emitting diode, varactor diode, photo detector, like there's so many applications are there. In the modulation also, PN junction diodes are used like that. So here I give this one simple example: diode as a rectifier application. So the rectified converts AC to pulsating DC. So or rectified converts bidirectional signal into unidirectional signal. So here see, this is a rectifier circuit, diode resistor. We are taking output across the resistor and giving input to the transformer. This transformer is giving the input. Input is a sine wave, bidirectional signal. It has both the positive direction and the negative direction. So first we give the positive half to this transformer. This may be step down transformer, and after that the same amount voltage is given to the diode. So in positive means the p type of the diode is given to the positive terminal, n type is given to the negative terminal, plus minus. That means the diode is in the forward bias condition. Forward bias means short circuit. Whatever the amount of the voltage we applied at given as an input, the same thing is applied across the resistor. We are taking output across the resistor. So what will get output? Same as the input. Whatever we are giving the input, the same input is applied across the resistor. That same output is as the output. Then negative half minus plus. The P terminal is given to the negative, M terminal is given to the positive. Diode is in the reverse bias. Reverse bias means acts as a open circuit. Open, so there is no flow. Block. The entire the voltage we have given is blocked here, and we are taking output across the resistor. Output across the resistor. There is no flow. The output across resistor is 0. So in the negative half cycle, the output is 0. So then positive half cycle, the output same as the input. Like that, the bidirectional signal is converted into the unidirectional signal. This is one of the application of the diode. So here, in reverse bias, there are two type of the breakdowns occurred: avalanche breakdown and the Zener breakdown. See here, what is avalanche breakdown? In the reverse bias, whenever we are increasing the reverse voltage, the minority charge carriers are get higher energy and they break down from the covalent bonds, and the released electrons have the get energy and they collide on another bonds, and there is a release of the electrons. Like that, the number of multiply of charge carriers will release that affect the breakdown of the diode. So lightly doped semiconductors avalanche breakdown, carriers generated by the collisions and breakdown voltages in the high. Next, what is the Zener breakdown? When diode is in the heavily doped, the depletion layer becomes extremely thin. So if a reverse voltage is increases, the electric field across the depletion layer becomes very high. This high electric field causes covalent bonds to break, so to create the electron hole pair within the depletion region. So hence a large of charge carriers generated with this result high current. Such mechanism called as the breakdown mechanism. Zener breakdown method. In avalanche breakdown, lightly doped semiconductor, the high current by the collisions. Here the Zener breakdown, heavily doped semiconductor, the carriers generated by the high electric field, breakdown voltage is low. Here the breakdown voltage is high. See, diode resistance. For ideal diode, the resistance is 0, but ideal diodes are not available. We have the practical diodes only. So what is he will see the diode resistance, DC resistance, AC resistance. DC or static resistance. The resistance offered by the diode to a DC applied voltage is called the DC or static resistance. See, in the forward bias condition, applied voltage and current through the diode, VI characteristics. At any point, take the applied voltage and corresponding current. The ratio VD by ID is called the DC current, approximately in terms of the ohms. In the reverse bias, this is approximately in terms of the mega ohms. AC or dynamic current. The same whenever the AC applied voltage is applied to the diode. So AC, the ratio we will take for the AC, the ratio, the rate of change of applied voltage to the rate of change of the current through the diode. So VD applied voltage, current. So this is approximately in terms of the ohms. In the reverse bias, the AC resistance will be infinite. Diode capacitance. Transition capacitance. When PN junction diode in reverse bias, the width of the depletion layer increases. So see here, the capacitance, the positive plate and negative plate, there is a dielectric material. So like this acts as a dielectric material, positive plate, negative plate. So in the reverse bias, there is a formation of the capacitance at the junction. This capacitance is called the transition capacitance. The CT is equal to epsilon. That means epsilon is the relative permittivity, area cross section of the junction, width of the depletion, width of the plates, the width difference between the two plates. That means the transition capacitance is inversely proportional to the width of the depletion layer, we can say. In the reverse bias, the width of the depletion layer increases. That means the transition capacitance decreases. So here in this graph, Reverse bias means the negative applied voltage. Uh, Applied voltage is increases, the width of the depletion layer increases, then the transition capacitance decreases. So applied electric voltage increases, the transition capacitance decreases. Diode capacitance and diffusion capacitance. In the forward bias, see this forward bias, at the junction there is ions, positive charge and negative charge, and this is the dielectric material, uh, the width difference between the two plates. That capacitance is called the diffusion capacitance. Tau is the mean lifetime for the holes, and other I is the current through the diode. That means the amount of the charge carries flow from P to N and N to P. Vt is the volt equivalent temperature. Eta is the intrinsic semi constant. This is different from the silicon and the germanium. See here, the I CD is directly proportional to the I. In the forward bias condition, applied voltage increases, x-axis applied voltage increases, current through the diode increases. That means whenever the current through the diode increases, the diffusion capacitance increases. So diffusion capacitance increases with respect to the applied voltage. Current components in a diode. So here till now we know that only uh, p side electrons move, n side holes. P side holes move, n side and electrons will move, consider the current. But in reverse bias we know that there is a small amount of current due to the minority charge carriers. Here, so the total amount of the current in p side is calculated. Total current I is equal to here C. What is I means current, Pn means the first suffix is the amount of the current due to watt carriers, and second suffix is type, p type or n type. So IPN means the current due to holes in n type. INP means the current due to electrons in the p type. So the total current in p side is the current due to holes in p type plus the current due to electrons in p type. That means the majority charge carriers current plus and minority charge carriers current, the total current in P side. At the same time in N side, the current due to electrons I N N plus the current due to diffusion of the holes. That means the diffusion current decreases with respect to the distance from the junction. At the junction there x equal to 0, IPN of 0 and INP of 0. After that, while the extra distance is increases, moving away from the junction, the diffusion, that means the minority charge carriers current decreases with respect to the distance. Here see, the total current in the P side IPP of X, that means the whole current in P side plus electron current in the P side. The total current in the N side, the same, the electron current in N side plus whole current in the N side. Thank you.